Hello students, welcome back. Today's class we are discussing the remaining part of the polymers. So first part we discussed the classification. So structures we are going to discuss. This is very important part. So let us concentrate on the board. Addition polymerization. Polymer is formed just by adding monomers. The first one is high density polythene. Monomer is ethene. Catalyst is very important, my dear children. Ziegler-Natta catalyst. Titanium tetrachloride, aluminium triethyl. Titanium tetrachloride and aluminium triethyl. Sometimes even they'll give trimethyl. So we are getting polythene, high density polythene. So what is important? It is chemically inert. It is an example of homopolymer. Synthetic polymer which is prepared in the laboratory. Next one is linear. Very important. Difference between high density and low density polythene is high density is linear whereas low density is branched. Difference is that catalyst also varies. Thermoplastic and example of addition polymer. It is used in the preparation of tubs, mugs and toys. Catalyst is important, Ziegler-Natta catalyst. Whereas low density polythene, monomer is ethene, it is peroxide. That is the reason on water bottles it's clearly written, after use crush it, don't expose to sunlight. So here it is an example of homopolymer. Synthetic polymer, difference is this is branched, this is linear. Thermoplastic, and it is undergoing free radical addition reaction, and poor conductor which is used in the preparation of toys and flexible wires. This use is also very important. So next one, PTFE, polytetrafluoroethene, which is the monomer is tetrafluoroethene. Also we are calling Teflon. Catalyst, persulfate, NCRT examples. So this is homopolymer, one type of monomer, synthetic, thermoplastic, addition. And it is generally used non-stick cookwares. So that is the reason my sincere advice is don't use non-stick pans. So gaskets, non-lubricant bearings are used for this preparation. Next one is pan, very important. Polyacrylonitrile pan. Monomer is vinyl cyanide, also we are calling acrylonitrile. So which is homopolymer, synthetic, thermoplastic, addition polymerization. Very important. It is a substitute for wool, which is also we are calling Arlan. Next one is condensation polymerization. Polymers are formed just by eliminating simple byproducts like water. So here the first one is terylene or decaron or polyester. Last class we discussed the monomers list I gave. It is ethylene glycol and terephthalic acid. Structure is this. So ethylene glycol and terephthalic acid, by eliminating water they formed. Very important. So it is example of copolymer. Terylene is an example of fiber. Next one is synthetic polymer. It is prepared by condensation polymerization. Terylene generally used in tire cords and seat belts. Very important. Nylon 6,6, so many times they asked. It is a polyamide. Copolymer because hexamethylene diamine and adipic acid. Fiber, synthetic polymer, condensation polymerization, elimination of water. Hexamethylene diamine and adipic acid. Both are 6-membered, therefore we are getting 6,6. 6 carbons are there. Nylon 6 also very important, no? Caprolactam monomer structure is this NHCH25CO taken N times, which is used as homopolymer, fiber, synthetic and condensation polymerization. It is used in the preparation of carpets and fishing nets. Fishing nets also used. The most important is bakelite. The monomers are phenol and formaldehyde. Very, very important. First we'll get an intermediate formed in the formation of bakelite is Novoloc, which is used in paints. Initially, this question commonly they are asking. So initial reaction is an example of aromatic electrophilic substitution reaction. This is the final structure of bakelite. So which is copolymer, thermosetting, condensation polymerization, polymer, synthetic polymer, three-dimensional polymer. Uses, if you observe, in the preparation of pens, in the preparation of combs, switches, and wooden planks are prepared by using this. So next one is biodegradable polymers. Polymers which are generally degraded by microorganisms. We are calling biodegradable polymers. Examples are very, very important. So PHBV, 3-hydroxy. So biodegradable polymers are very, very important. First point is aliphatic polyesters. The most important example, 2018, 2017, also they asked. PHBV is a copolymer of 3-hydroxypentanoic acid which gives elasticity. This is very, very important. Not there in NCERT but asked so many times. 3-hydroxybutanoic acid which gives one is PGA, polyglycolic acid, PLA, polylactic acid. Polylactic acid generally used in post-operative stitches. 2019 this question is asked. The monomers in nylon 2,6. Glycine and aminocaprolic acid, which is a biodegradable polymer. Next one is first biodegradable polymer material is dextran. Dextran is nothing but combination of polyglycolic acid and polylactic acid. Commercially, we are calling dextran. First biodegradable polymer generally used post-operative stitches. So next one is natural rubber. So which is cis polyisoprene, very, very important. The monomer is isoprene. IUPAC name is 2-methyl 1,3 butadiene. Next one is it is nothing but extracted from rubber plants which contain 30% of latex, which is emulsion, and it is a linear polymer of isoprene which contains cis 1,4 polyisoprene units. Cis 1,4 polyisoprene. Natural rubber contain only cis configuration, but one has trans configuration. Its name is Gutta Percha, which is trans polyisoprene. So next one is natural rubber is a soft, brittle, and it has high water absorption capacity. To prevent that, we are adding sulfur. That addition of sulfur we are calling vulcanization. So to the natural rubber, in presence of zinc stearate and zinc oxide, if you add 5% of sulfur, that process we are calling vulcanization of rubber. Vulcanized rubber contain 5% of sulfur, and highly vulcanized rubber we are calling ebonite, which contain 20 to 25% sulfur. Very important, my dear children. Battery cases, 30% sulfur. So the active sites are double bonds. Double bonds are converted into single bond with the help of sulfur linkages. So finally, Molecular weights is not there as per NCERT, but questions are framing. Molecular weight of polymers we can calculate number average and weight average. So this is very very important. Natural polymers, polydispersity index will be 1, whereas for synthetic polymers, polydispersity index will be greater than 1. This is in brief about polymers, but please do read NCERT. If you like this video, do share and like it. Thank you, your SVS.